Okay, as it says, it's best understood by looking at an example, because we've talked a lot about coefficient k plus 1, terms, etc. So let's get on with the example. You can see in this binomial that the coefficient is not going to be the binomial theorem coefficient alone. It's not going to be NCK alone, because the presence of this 2 in the binomial is going to contribute to a coefficient anywhere in the expansion. And this coefficient of 3 is also going to contribute to a coefficient within a particular term of the expansion. So number 1, or part 1, just says write the expansion in sigma notation. So we will have 2 plus 3x to the 12 is going to be the sum of terms, okay, starting at 0 up to 12. And we'll have NCK starting at 0. But it would, if k was 0, we'd be talking about our first term. We know that's going to be then have 2, that should be a 12 back there. Two to the 12 minus k, and 3x to the k. Let's move on. Identify the coefficients of tk and tk plus 1. So although we've talked a lot about confusing notation, there's nothing really confusing about this. There's nothing. tk will contain the NCK term. It will have the x to the k term in it, just like tk plus 1 will have NCK plus 1. And because this is strictly the coefficient only, you can't see the x to the k term in it. Okay, so we go back to here and we're substituting k as k. So we know that we want 12ck 2 to the 12 minus k. There would have been originally 3x to the k, but the only part of that contributes to the coefficient is 3 to the k. And if you look at these are the answers over here. You can see we've got it correct. So that would be tk. The coefficient called tk plus 1, the next coefficient after that would be 12c k plus 1, 2, now I'll do it the long way, 12 minus k plus 1, 3 to the k plus 1, which we need to tidy up this power. It's 12c k plus 1, 2, 12 minus k minus 1 gives us 11 minus k, 3 to the k plus 1. Checking with the answer, 12c k plus 1, 2 to the 11 minus k, 3 to the k plus 1. So we're correct. Now, like I said, much of the questions actually just test that you can simplify that ratio So it's telling us here that they want us to show that the ratio simplifies to this. The good thing about a question like that is, even if you get lost in simplifying this fraction, which remember I said before is going to have a fraction at the top and a fraction in the bottom, and it's going to have factorials in those fractions, even if you do get lost, you know that you can still use this ratio and continue on the rest of the question, as is down here, even if you hadn't been able to show that it's this ratio of coefficients simplified to 36 minus 3k, you could still use it, and you would do that in a question, even if you get in the middle of the working here for part 3 and it's not working out and you're not getting to the 36 minus 3k over 2k plus 2, abandon it, but still continue with the question. Just abandon that part. Okay, let's see how we go. So we want the ratio of the bigger coefficient over the one before. So t k plus 1 on tk becomes 12c k plus 1 2 to the 12 minus, 11 minus k 3 to the k plus 1 all over 12ck 2 to the 12 minus k 3 to the k. Now, I'm just going to pause it, fill out the rest of it, and we'll come back and talk about it. Okay, so we're up to writing out our definition for 12ck plus 1, which is 12 factorial over 12 minus k plus 1 factorial, k plus 1 factorial. We've got our 2 to the 11 minus k, 3 to the k plus 1. Writing out our expansion for 12ck, we've got it as 12 factorial, 12 minus k factorial, and we've got the other part to our coefficient. Now, what I've done is I've taken this top fraction divided by the bottom fraction. When you have one fraction divided by another, you invert and multiply. So you see the top fraction sitting here, and the bottom fraction has been inverted, and I'm multiplying. Here I have simplified with 2 to the 11 minus k. To simplify this, I subtract this index, 12 minus k, and same with 3. Now, let's have a look at what actually happens when I simplify these fractions. The 12 factorials disappear. If I think about 12 minus k factorial, so what does 12 minus k factorial mean? It's 12 minus k times 1 less, which would be 11 minus k. But hang on, we've got 11 minus k factorial in the denominator, so all of that cancels out with that factorial. Likewise, here we've got k plus 1 factorial, which means k plus 1 times 1 less, k times k minus 1, etc. But we've got k minus 1 factorial up there, so that cancels out with this factorial aspect. 11 minus k minus 12 plus k eliminates the k. 11 minus 12 is minus 1. It's 2 to the minus 1, which puts it into the denominator. 3 to the k plus 1 minus k is 3 to the power 1, so 3 stays on the top. So all we've got left on the top is a 12 minus k and a plus 3. In the bottom, in our denominator, we've got a k plus 1, and this 2 came to the denominator. When we expand that out, we get 36 minus 3k over 2k plus 2, which is what we were required to show. Now, to show that T7 is the greatest coefficient, and please don't confuse that with the 7th term. No, coefficient 7 belongs to the 8th term in the expansion. But let's do this fairly simple solving an inequality. Tk plus 1 over Tk was this 36 minus 36 minus 3k all over 2k plus 2 has to be greater than 1. It's a very simple little inequality. Multiply and you'll get 36 minus 3k is greater than 2k plus 2. So 36 minus 2, 36, 34 is greater than 5k, which gives that k is less than 6 4/5. Now, if k must be less than 6 4/5, then, and k is a whole number, k is equal to 6. But remember, we're looking at the ratio of coefficients, and it was k plus 1, which would be the greater coefficient. So k plus 1 is 7. Our greatest coefficient, lowercase t, is 7, but the point I really want to make, which I don't think this textbook does very well, is that it is the 8th term in the expansion. You can now have a go at exercise 5e.